All right, everyone, this is Mr. Ben from Washington, D.C. This is 8th grade math. Jump into this work. All right, so our goal is we're going to dilate a rectangle from a point of center inside of the rectangle. Okay, so here's what I mean by that. Here's our rectangle, and you see that I located this point of center P in the center of the rectangle. Okay, so we have center P, and we're going to use a scale factor of 1/2. We'd even put around center P. That means for every coordinate we identify, we need to use a scale factor of 1/2 to find the new coordinate. So for example, our point A is 4, 6, so 4, 6. After we use a scale factor of 1/2, people use the letter K for scale factor, and a scale factor of 1/2, think to yourself, is this going to make the rectangle and the point farther away from the origin and a larger overall, or is it going to make it smaller? Well, the scale factor, if it's more than 1, it makes the image larger. If it's a fractional amount between 0 and 1, we should expect the object to shrink or to get smaller. So keep that in mind as you do this. Okay, so A prime, 1/2 of every number. Multiplying by 1/2 is the same as dividing by 2. So 4 times 1/2, or 1/2 of 4. 1/2 of 4 is 2, and 1/2 of 6 is 3. All right, so go over here. A prime is over 2 of 3. Put a little A prime there. All right, let's go through B, C, and D a little quicker. So point B up here is over 4 to the left. So -4, +6. Point C is +4, -6. And point D is -4, -6. Now let's apply our scale factor of 1/2 every time. All right, so our B prime will be 1/2 of -4, -2, 1/2 of 6, which is 3. C prime, 1/2 of 4 is 2, 1/2 of -6 is -3. And finally, D prime, 1/2 of -4 is -2, 1/2 of -6 is -3. All right, let's plot these points. So B prime, -2, 3. -2, 3. B prime. C prime, 2, -3. Over 2, down to -3. C prime. And D prime, -2, -3. Over to -2, down to -3. D prime. I'm going to try to connect these dots, but my pen is a little shaky, so we'll see how this goes. So over here, and we see that it's going to form a smaller rectangle, right? Here, here, here. All right, so using a scale factor of 1/2, we see that the image got smaller, and it's really interesting that it kind of gets smaller around the origin. You took each coordinate, and we applied the scale factor to that coordinate, using the origin as our center point, or that center point that happened to be in the center of the rectangle. Okay, we're going to do the same thing with a green triangle this time. We're still going to use a scale factor of 1/2. Around center, I can't even see that says 1/2. 1/2 around center P. Okay, this time let's just start with every coordinate. That way we just get them down. All right, coordinate A is 5, 3. Coordinate B is -5, +3. Coordinate C is 5, -3. And coordinate D is -5, -3. All right, so we need to apply that scale factor. K equals 1/2. Remember, K is just another way of putting scale factor. And we're going to get our new coordinates. Just an arrow just shows, like, me in my mind, like, hey, I'm doing the scale factor to every coordinate. Okay, so A prime. Some people get tripped up because, like, what's 1/2 of 5 or 1/2 of 3? it doesn't like work out perfectly. Remember, if you have a calculator, doing times half is the same as just dividing by 2. And half of 5, or 5 divided by 2, is 2.5, or 2.5. Half of 3 is 1.5, 1.5. All right, B prime. Half of negative 5 is negative 2.5. Half of 3, we know, is 1.5. All right, C prime. Half of 5 is 2.5. Half of negative 3 is negative 1.5. And finally, D prime. Just going through all the coordinates. Half of negative 5, negative 2.5. Half of negative 3 is negative 1.5. All right, let's plot these coordinates. All right, so A prime, 2.5, 1.5. Watch how I do this. Go over to between 2 and 3, so that's 2.5, and go up 1.5, so between 1 and 2. And it's okay that it doesn't go on straight on the grid. We're just plotting the coordinates as best we can. All right, B prime, negative 2.5, up 1.5. So negative 1, 2.5 would be right here. Up 1.5 would be here. Remember, it forms a rectangle, so you can kind of like be double checking the formation as you go. All right, C prime, 2.5, negative 1.5. So over to 2.5, down negative 1.5, C prime. And D prime, negative 2.5, negative 1.5. So you can see that even when a scale factor of half creates kind of like these fractional amounts like 2.5, 1.5, you can still plot it carefully and still make it work. Okay, the last thing I want to show you is something on just GeoGebra. So take a look at this image. This is just a triangle. Center of origin is the origin, the center. And when you use a scale factor of 1, it's right on top. Scale factor greater than 1, you see that every coordinate, in this case, gets multiplied by 2 because our factor is 2. Scale factor of 3, look, every coordinate is multiplied by 3. Look, 5, 2 becomes 15, 6, multiplied by 3. Let's shrink it back to 2. Still a larger image than the pre-image. Put it to 1. It's overlapping exactly. Let's put it to half, 0.5. That's a scale factor of half like we just did. And look, 4, 5 becomes 2, 2.5 because 4 goes to 2 because of half, and 5 goes to 2.5. Okay, I wanted to show you that because when the center is the origin, it just looks different the way you dilate a triangle. All right, thank you for joining me for this video. We dilated a rectangle, we dilated a triangle. Using the scale factor of half was really important and to see what happened in that case. All right, bye.